welcome to the stage founder and chairman of the XPRIZE Foundation and co-founder and executive chairman of Singularity University, Peter Diamandis, as well as co-founder and CSO of Regenerative Medicine Institute, Dr. Vincent Giampapa, and the CEO of BioViva Sciences, Liz Parrish.
Let's go. You're in next. Hey.
Up. I'll go this way.
Sit over here.
Thank you.
Hey guys, welcome.
It is so great to be here.
Hello everybody.
Buddy.
Yeah, that's a much better response. That's great.
Woo!
There we go.
Let's go.
So this conversation is going to be for those of you who love life and want more of it. Hopefully that's you. Yes? Great. Take a second to introduce ourselves a little bit further. Peter Diamandis. I am someone who is passionate about driving breakthroughs in a wide range of areas. The last decade, it's been really a focus on extending health span and longevity. Have founded some 25 companies, a few different books. You may know my work from the XPRIZE Foundation as well. And I'm proud to be on stage with these two amazing pioneers and researchers. Liz, would you say a few words about yourself?
Oh, sure. So I'm the CEO of a company called BioViva. I've been in the regenerative medicine space for 11 years, but the last 9 years have been focused on genetics after the diagnosis of type 1 diabetes of my son. So I became very interested in why we die and actually how we could stop that from happening. So that became a necessity case in order to do that. And since then, we've touched a lot of lives, and we hope to touch yours as well.
Vince.
Yeah, so my background goes way back to forming the A4M, American Academy of Anti-Aging Medicine. Close to 30 years ago, I was one of the founding members. I was first president of the American Board of Anti-Aging Medicine, which helped us really formalize how we treat doctors to treat the aging process. My last decade has been really focused on putting together what I believe is a world-class stem cell institute, the Regenerative Medicine Institute in San Jose, where we're in an environment where we can do things that we could never do here. And we've helped hundreds, if not thousands, of people with stem cell therapies that should have been available here, or in the United States, I mean. And we're looking forward to a whole range of all new technologies that will really take health span and longevity to another whole level.
I should mention, while I'm an MD, I've never practiced. Vince, on the other hand, has spent many years in surgery and medicine and regenerative medicine, so thank you, Vince.
Thank you, Peter.
What I'd like to do is I'm going to give a little bit of a overview on this field, give some context, what I think is very important, and set the stage, and then have a fireside conversation with Liz and Vince. So we're in a coming age of longevity, and the next decade is very different than the last century. And I want you to realize that in your heart and soul. And if I can get the clicker working, there we go. We forget how amazing the world is and how rapidly we're progressing. I love this saying that our ancestors would consider us as gods. We're in a period of time where it's not just any one technology, but it is a range of these exponential technologies that are all converging and reinventing every industry. And for me, the most important industry that they're reinventing, besides every other industry, is healthcare and longevity. You know, there's no greater wealth than our health, and I think if we had the ability to bestow upon those we loved extra decades of health span, I think that's the one thing that we might choose. So what's going on, what's making this decade different is in fact AI. AI is driving this longevity and health span revolution. There's a quote, I had Elon on my stage last year at the Abundance Summit, and said by 2029 or 2030, digital intelligence will exceed all human intelligence combined. And that is what's fundamentally not considered when we look at the implications of our future. This is Moore's law on that first slope. This is a doubling every 2 years of computational power. We've entered a period of time where we're seeing a 10x increase per year, and it is accelerating. And this is what's enabling things to occur. My co-founder of Singularity University, Ray Kurzweil, said 2029 is when we'll get human-level intelligence. Elon's prediction was 2025 is where they'll be vastly smarter, and 2030 is where AI will be more intelligent than the entire human race combined. And I believe him. And this is data coming from a multitude of places. The health span revolution, and to talk about this, I want to give some context. We were never designed to live past age 30. So if you're under 30, congrats. If you're over 30, it's all downhill from here. We would be in puberty at age 12 or 13. We'd be pregnant, immediately. By the time we were 26 or 27, our kids were having kids. We were grandparents. And if you wanted to perpetuate the species, the very best thing you could do was die and not take food from your grandchildren's mouths. This was a time where food was not abundant. There was scarcity everywhere. And so if you look at every aspect of our body, from our stem cell populations to our hormonal levels to our thymus, it is a very rapid decrease after the age of 30. So one of the questions is, how long might we live? I think many of us know people some people finally got it here. Some people might know that folks who make it to 100. And I think there's a pretty good probability that many people here, if you take reasonably good care of yourself, can make it into your 90s and even get to 100. But did you know that there's a species of bowhead whales that could live to 200 years old? And that the Greenland shark could live to 500 years old and have babies at 200 years old? And when I was in medical school, I asked myself a very simple question. If they can live that long, why can't we? And I said, it's either a hardware problem or a software problem. And we're going to have the technology to fix that. And that's what we're seeing before us in the next 10 years. Here's another point I wanted to give context. When you're born, you have 3.2 billion letters from your mom and from your dad. That software is the entire software that you're running throughout your life. You've got the same genes when you're 20, when you're 50, when you're 100. So why don't you have a six-pack when you're 100 years old? Why do you look differently? It's not the genes that you have, it's which genes are on and which genes are off. It's your epigenetics. And the hottest area of research right now, and we'll hear some about this, is epigenetic reprogramming. Can we turn back the clock of time? We're seeing amazing things like CRISPR-based cures for a wide range of diseases. We've seen a Nobel Prize given out for AlphaFold, AlphaProteo, the ability to design in AI the perfect protein that's needed to cure not any disease, your specific disease, for your genetics. One of the things I'm proud of is I launched about a year ago this month the largest XPRIZE of its time. I raised $141 million for a $101 million purse to reverse by 20 years your muscle loss, immune loss, and cognitive loss, right? To bring you back 20 years younger. And this is one of the teams competing in that competition. You'll hear about them in a moment. And it needs to be delivered in a therapeutic of under 1 year. We have 460 teams competing for this, and so proud of what's going on there. When I think about this, there are two parts of this journey. One is the diagnostics, not dying from something stupid. The second that we'll talk about here is the therapeutics. So I'll just point towards the diagnostics and ask the question, do you know what's going on inside your body? For most of us, the answer is no. Right? I had started with Tony Robbins and Bill Kapp, something called Fountain Life, to do this. It turns out that 70% of heart attacks have no precedent. They just have it, and half of those folks are dead. You don't feel a cancer until stage 3 or stage 4. 70% of fatal cancers are from like glioblastomas or pancreatic cancer, which we don't normally scan for. right? So the question is, how do you know about these things? You have to look. And there's a revolution in diagnostics that's going on right now. In fact, our belief is that you can, in fact, prevent at least 7 out of the top 10 causes of death by this multimodal combination of imaging, genetics, biomarkers, and AI. It's now possible to know what's going on right now and what's going to happen to you and how do you optimize yourself. Fountain, we have 4 centers today. We'll be announcing our next 4 centers in 24-25 and then on a growth path for an additional 25 centers. Here's the results, just to give you a little bit of fear. 2% of people who come through our centers, we find a cancer they don't know about. Right? We're all optimists about our health. 2.5% have an aneurysm they don't know about, and 14.4% have neurocognitive disease, cardiovascular disease, metabolic disease, something that they urgently need to take care of right then. I'll skip through these, but there are amazing diagnostics that are available across the board. And at the end of the day, right, it's understanding your genome, toxins, microplastics, gut, microbiome, all of these things impact you. But at the end of the day, it is, in fact, not dying from something stupid, understanding that your body is beginning a slow glide down after the age of 30, and then saying, I refuse to let that go on any further, which is where my colleagues come in, which is how do we deliver you therapeutics that are able to regenerate your body, take you back to an optimal state of health. So I'm going to turn to you guys.
Well, Peter, first I have a thing.
Yeah.
I hear you're coming out with a new book. I'd like to hear a little bit more about that.
So next month in December, I've got a book called Longevity Guidebook. Thank you, please. It's really focused on what you can do right now in terms of diet, exercise, sleep, mindset. I'll give you one key point, and this is a great room for it. A study of 69,000 women, 1,500 guys, one of the only studies more women than guys, found that optimists live 15% longer than pessimists.
Yeah, I saw that. That's amazing.
And you get a double benefit for being an optimist. So please join me in being optimistic. But the book then looks at all of the coming regenerative medicine. It's really, the subtitle of the book is how to slow, stop, and reverse aging and not die from something stupid. So super excited about that coming out. All right, let's jump in, and I've got some fun questions for you guys. So let's begin first with how did RegenCell come about?
I'm going to let you take that away.
So, my whole focus has been on...
And explain what RegenCell is.
So RegenCell is a company that Liz and I have decided to put together the technologies we've been developing for over decades. That is a combination of stem cells and specific genes where we can create a personalized approach, not just to dramatically impact the hallmarks of aging, but also to reverse some of the genetic gene activity profiles that basically cause the functional loss we all have. Loss of cognition, loss of muscle, loss of cellular energetics.
Sort of defend ourselves against what Darwin gave us.
Exactly. So we decided how do we think out of the box and literally impact what we know are all these processes that occur with the hallmarks of aging? How can we literally turn those down, but at the same time, I think, restore one of the most important hallmarks of aging, which is the loss of your stem cells. That's your human regenerative system, is really the fact that we have stem cells. But why does that go bad? Because we lose the numbers.
And stem cells in every compartment of your body, right?
Every compartment in your
body. And what's
body.
The order of magnitude of the stem cell reduction that you get over your lifespan?
So we're going to have a slide to show that, but
okay.
Frankly...
Do you want to go forward to that
Yeah,
slide?
let's go to the next slide. So as you see, we're literally born with a fixed number of stem cells. So by the time we get to be age, we're 18 adults, we're lost 60% of those stem cells that we're born with.
That pisses me off.
We're hit 30, we lost 75%. And by the time we're 60, excuse us, because there's many of us in that, We're down to 5%. Now, we're talking about 3 types of stem cells. The stem cells that are responsible for your immune function, those that are responsible for maintaining your blood vessels and keeping blood flow to your organs. And the third type, probably the most important, or one of the most important, is our mesenchymal stem cell that can turn into muscle, bone, cartilage, brain tissue. So imagine you're now 50 or 60, and your body cells are accumulating all this damage, but you don't have the stem cells you had when you were 30 to fix that. So what happens is we lose health span. We're starting to decrease our potential for cognition, for function, but also we're getting towards the last decade of our life when we shouldn't be. So the regen cell the whole purpose was to undo this and to come up with a way which we believe we've done.
And I'll take us back a slide and go over the genes. So if
we'll go back. You want to go back?
Thank you. So our company on my side that Vince was reaching out to, and I was so happy that he did, and we formed this new company, we actually focus on genes that target the hallmarks of aging. So when we look...
Can I take 1 second?
Yeah, sure.
There was a paper published in Cell years ago that looked at what are the root causes of aging. And they originally had, was it 9 original?
Yeah.
9 original.
And now it's 12 or 13.
Yeah, and
So these are like the reasons that we age, right? Like, why do we age? I don't know. Well, they decided to come up with a very specific set of reasons. And stem cell exhaustion is one of them. And you went after the genes instead. Yeah,
so we actually decided to focus on the genes because you can get a large impact by doing that. And with gene therapy, what we can do is we can give you the therapy. The therapeutic goes into your blood system, and it targets a multitude of cells in your body, thereby replacing the genes that either go down as we age or ones that were not turned on in cells, the Darwin problem. So most of the super long-lived species, or the ones that we call immortal species, have a gene called telomerase reverse transcriptase turned on. So when we upregulate this one gene, we have a paper out in PNAS, we were able to get 41% life extension in mice. And mice don't typically die of telomere attrition. It's just one of the things that affects them. What that means is if we took that and it was equivalent to humans, if you were going to live to about 79 years, you would easily, with that one single gene, live to over 110. So that's a super big impact from one gene. But we're a George Church company, and George Church, if you don't know, is he works at Harvard. He's a professor of genetics, and our goal is multi-gene combination.
He's the Midas touch. He's started how many unicorn companies?
Oh, like lots. Yeah. And the whole idea of the company is to get an affordable gene therapy that is a multitude of genes, and we'll talk about that later in the talk.
Are you going to talk later about adeno-associated virus and the carrier vehicles and what a gene therapy is, or should we mention that now?
I think we do have a slide about that.
Okay.
And so anyway, when we look at these genes, and these are just a few of the genes that we work with, they all target some parts of hallmarks of aging, the initial hallmarks or the new hallmarks. And again, this list will grow. And some of the hallmarks, of course, are an offset of the original hallmarks going wrong. But telomerase reverse transcriptase, and I'm just trying to put this into your mind, just one single gene can target multitude of hallmarks. And then when we bring in the other players, the idea is to get the super wave of output. So how do we make it so you live as long as you want?
So if you don't mind, just to put it in context, what you've been doing is using gene therapies, again, the ability to inject a specific gene into specific cells, muscle, kidney, lung, brain.
Yes.
Do you have concerns about the safety of that process?
You know, that's the beautiful thing about what we do at BioViva. We do somatic cell delivery. So we're not actually doing CRISPR, we're not editing the genome, and what we're doing is creating an episome. So what that means is...
Can I ask a question before you
sure.
Are you willing to talk about what you've done to yourself?
Yeah, and there's a slide about that. So this slide just shows you what gene therapy is. Essentially, the gene therapy is going into the nucleus of the cell and transcribing for a gene. And the gene then codes for a protein, and that changes you. So all of the cells of your body have genes in them, and they have your chromosomes in them, and that really is an expression of who you are physiologically. It can have some expression in how we behave. We know that the microbiome, also that genome, makes up how we are as well, so editing that will be an interesting thing to do in the future. But I was so excited about this technology, we'll move right forward to your question, that in 2015, I was the first subject to treat biological aging with gene therapy.
Now, you have to understand, when I first heard, Liz, that she did that, I was like, holy shit, that's amazing. How ballsy of you. And where can I get myself some? Was the next. So you have to understand, you did this with an AAV, right?
Yeah.
So an adeno-associated virus is a virus, you take out the viral genome and you put instead inside this capsid the gene you want delivered. And the virus is a robotic heat-seeking missile that goes to the right cells, injects your gene of choice into those cells.
Exactly.
And it goes in, you said, as a plasmid? Or
as an episome.
Episome.
Yes.
So like a microchromosome.
So
Yeah.
this is really important, and I know I don't mean to interrupt.
Oh, no, please.
But here's the thing. That gene doesn't get incorporated into the cell's genome. So it's sitting in the nucleus.
In the
As a-
nucleus,
to
not the
answer your
cytoplasm.
It's inside the
No, in the
nucleus.
nucleus.
The cytoplasm within the nucleus, and it's like a new chromosome, but it's not in any way interfering with your personal genome.
Right.
So that new gene produces a protein that goes out of the nucleus to the cytoplasm, goes to the cellular machinery and creates the protein that normally the cell, for instance, if you were 25 years old, you'd be making a lot of follistatin to keep your muscle mass up. Well, and for instance, one of the genes that we're looking at putting in now in stem cells is follistatin, and what's already being used without stem cells, but with unbelievable impact in augmenting muscle mass without interfering with your genome.
So the idea here is you've been dealt a set of cards from your mom and your dad, and they are what they are. And by the way, as you age, certain genes get silenced, and certain genes get turned on and off, and sometimes it's the genes you don't want turned on or the genes you don't want turned off.
Yep.
And this gives you much more control. How many gene therapies have you done to yourself?
I've done 7 gene therapies, 4 different genes.
4 different genes. And you mind just rattling off what they are?
Yeah, so alpha-klotho, it's associated
klotho-
with better cognitive performance.
How many? We had this over lunch. What kind of IQ points have you scored?
On average, in patients, we can increase their IQ by a standard deviation. So anywhere between 9 and 15.
These are the holy shit moments that you guys should enjoy.
And this is a single injection, probably maybe only once in your life. And that is the power of that. For some people, think about it. If you had someone who's very low performing, this could get them functioning and living on their own. If you had someone really high performing, this could be the difference between genius.
Yeah. Okay, so klotho is the first. What was the second?
So you're seeing here the slides of follistatin that was injected into my muscles. It blocks myostatin, so it increases your muscle mass. It should stay with you for at least 10 years. So you can see my muscles and my legs before and after. So after, there's increased muscle mass and less intermuscular fat.
Do you have a percent muscle increase that you know?
You know, it differs. Men get a better increase, and unfortunately, mice get the best. So if you just touch mice with follistatin, they will literally, like, you can look at our published papers, it's just like insane. They get really huge, really fast. We, not so much. But this is a gene therapy that's been through safety and efficacy in the United States with Becker's and Duchenne's muscular dystrophy. And it's been through, every animal model, including non-human primates.
Klotho, follistatin, what's next?
Telomerase reverse transcriptase.
Wow, that is ballsy to do.
I was the first person in the world to take that, and since then we have the data on many people who have taken it, and probably globally hundreds of people have taken it now through concierge medicine. And this is the graph that you're seeing on your right. And so there are different hallmarks of aging, as we talked about before, and I always say don't fall in love with one, because in reprogramming, we can do that. RegenCell can do that. We can do that with gene therapy. It's one hallmark of aging, but you really need to bring these all in. It's multiple modalities that will cure aging. And what we saw in these results, what you're seeing here, is my telomere length after gene therapy. So I took 2 gene therapies, one in 2015. I was the first person in the world to take it. People were very worried about that gene therapy, and I took it again in 2020. And what we've seen is for every year I have lived since taking the gene therapy in 2015, my biological age that's associated with my telomeres has reversed 5 years. Now that doesn't reverse all of aging, but as I said, it targets the most hallmarks of aging of any single gene. And we're talking about what we're working on now is delivering a string of multiple genes.
Amazing. All right, let's move on. Thanks. So
I just want to make a comment. I believe in this so much. She convinced me to go ahead and do very similar things.
Yeah,
So-
he recently took a gene therapy, so yeah.
and I know you, and you look amazing. Talk to me about where you're going next with this and stem cells, because you've come together now for a new strategy and approach.
So we really think we're looking at a new paradigm to treat aging in general. And if we can go to the next slide. Oh, we're on this slide. Okay, I'm sorry.
Go back one.
I didn't realize.
Yeah.
So if you take a look at this slide on your left, what you're going to see is as stem cells decline, okay, right about age 40, you start to really lose your stem cell numbers. That means you can't regenerate your immune system, your blood vessels, your regenerative potential, your tissues and organs. But if you look at what happens also at about the same age of 40, the body starts to accumulate what we call senescent cells. These are things that actually accelerate the aging process in your body and stem cells. So once you hit 60, it's a downward slide, and you have 15 years, maybe 20 years before you're dying, because you no longer have your regenerative potential to repair your body cells or even your stem cells. Now, up until 10 years ago, there was no way to fix this, and that hallmark of aging, there was no way to fix. 10, 12 years ago, I started giving back, collecting and storing all of these 3 main stem cell types and giving them back to patients to see how did they do. And we now have data that we've collected over 10 years. But people who've got back their stem cells and reprogrammed stem cells, which we did the first time in 2016, where our group in Rutgers actually got a Nobel Prize nomination for that. These people who have got their stem cells back with epigenetic reprogramming, that means just switching the genes back to a younger profile, are dramatically healthier. They're in their late 80s and 90s and doing phenomenal. That paper should be out in the next month or 2, and I think it's going to be a big thing. But if you take a look at these 2 curves, as your stem cells decline, so does your immune system. As your senescent cells increase, so does your chance of cancer and age-related diseases. So there's a direct correlation with stem cell numbers, quality of health span, and lifespan. But then how do we take the next step to really change this? And we have to alter what genes are active, or we have to put in a new gene to replace the activity that you used to have when you were younger.
So speak to what you're doing now to modify. So Vince also runs RMI, the Regenerative Medicine Institute down in Costa Rica, which I commend to all of you if you're looking for stem cell therapies and related. And historically, people have come down and you've basically been able to store their existing stem cells, right? Your stem cells will never be younger than they are at this very moment.
Right.
Until now.
Until now, you can then you can make them more youthful, right? You can euthanize them. Is that the right term?
That should be the new term.
That's a bad term.
I'm not going to say it. Okay. So, but you've come together now. You're a Reese's Peanut Butter Cup, and you've got a new strategy. So
I can tell you, I'll get started and then I'll hand this over to Liz. But for instance, we have 3 main types of stem cells, adult stem cells, that are really basically directly related to health span and longevity. We have a group of stem cells that are responsible for our immune function, hematopoietic stem cells. Now we're losing the functional quality of those stem cells year after year. But if we were to add H-TERT just to that type of stem cell, basically what's going to happen is our stem cells, our telomeres are going to get longer, and those cells are going to divide for perhaps decades and decades longer, which means we're not going to have immune decline. And immunosenescence is what basically every one of us is going to die from eventually. So that's a specific stem cell type with a specific gene. So let's say what happens with, we lose cognition because Klotho is directly related to not only longevity, cardiac health, renal health, but cognition.
And it's so hard to make. Making Klotho and delivering it as a drug is nearly impossible.
It's very difficult, right. So, but if we take a mesenchymal stem cell, which actually has the receptor sites on it, ICAM and VCAM, that are sensitive, for instance, to focused ultrasound, and we load that with Klotho, we can direct with ultrasound those mesenchymal stem cells with the gene for Klotho into the brain and start delivering the proteins right into the brain where we need to enhance cognition. And let's just look at one more. So we all end up with frailty. We hit our 50s, 60s, we're working out in the gym, we can't build the muscle mass we used to because follistatin is no longer being produced and myostatin starts to be produced, and it's inhibiting muscle growth. We learned mesenchymal stem cells, which are the precursor to muscle cells. With follistatin, we can inject those directly into the muscle, and this has already been done in children with Duchenne's muscular dystrophy who couldn't walk up steps. You'll see the video. A month later, they're running up the step. But why should we wait for a congenital disease? Why shouldn't we be using that for all of us?
We all have a congenital disease called death.
It's a terminal disease.
Yeah.
But so what we've looked at is how do we take specific stem cells with a specific gene for a specific age-related problem. I'm going to call these problems are basically what results in loss of function and quality of life and basically health span. So we're addressing the loss of stem cells with specific genes and specific stem cells and basically creating personalized aging treatments for each person. You may have just cognitive decline or frailty. You may only need one gene or two genes. But if we were to load all four of these genes, and
so
Liz is going to tell you how we can do that in the very near future.
Yeah, so, but walk me through this. I come down, you collect my stem cells.
Right.
You're taking this from peripheral blood?
So what we do, see at RMI, this is in San Jose, Costa Rica, and by the way, if anybody wants any more information about this, Dr. Mike is in the front row here somewhere.
Yeah, Mike Sinnell is the reason I'm here, Mike, thank you.
So what we do is we use a compound called Neupogen. And there's different types of what we call mobilizing agents. In fact, Liz just came down and had her stem cells collected. I've had mine collected 15 years ago. Okay. So what we do, there's a process for a few days. There are little tiny injections you give yourself. This mobilizes billions and billions of your stem cells. And it's actually your first treatment because your body's flooded with billions of stem cells you don't normally have repairing and restoring things. So you get your first treatment. While the blood is full of these regenerative cells, what we do is we collect very large numbers, we put them into cryopreservation, and then we can use them even right now as they are. In the very near future, we can use those for instance, helping to restore the loss of stem cell numbers, or there's other particular conditions that might arise where you may be able to use them right now. But the big focus is, and we'll talk about this in a minute, is to take those stem cells and reprogram them, their gene activity of those genes back to when they were in your 20s and 30s.
All right, so let me slow this down a second. I come down, I take the Neupogen, which causes my bone marrow to generate more stem cells. It goes to my peripheral blood. You bleed me. You collect the blood. You spin down the stem cells, and then you're going to give those cells a gene therapy directly.
Right.
Yes?
Now that's what we're setting up now to do. It hasn't been done yet, but that's where we have new patents filed on that, both internationally, nationally, in the detailed process of how this would be done.
So what I like about this is rather than giving yourself the virus, right, the adeno-associated virus is one of the potential carrier vehicles. You're working on CMV as well?
Yeah, that's right.
As an alternate, a larger capsid, being able to handle multiple genes versus one gene. Yeah. But in this case, you're giving the gene specifically to stem cells that are in solution. And
Your own stem cells.
Your own stem cells in solution. You're allowing them to get taken up, incorporated into their nucleus, and then how long does that take for that process to get? Do you get 100%, call it transfection or whatever you want to call it, and then how long does that take, and then you give it back IV?
Liz, explain how long. Go ahead. I'll let you take this.
Yeah,
how long
it'll
transfection
probably
rates?
take several days. You know, you can stay in the area, or you could travel back home and have a multitude of your cells reprogrammed and the genes actually put into the cells, and then getting them back into your body would just take literally, 30 minutes of your time, and then we're going to hone those stem cells either to specific tissues or organs, or hope that they go back into your bone marrow and set up shop and start making new healthy cells.
So when you think about stem cells, and I'm curious, how many folks have done any kind of stem cell treatment? I'm trying to see your hands, about 15, 20 or so. So stem cells come from a multitude of different options, right? You can get your own stem cells. You can go and get stem cells from a newborn, either umbilical cord or placental cells. You can also create induced pluripotent stem cells from your own skin cell. But this one is safe because it's your own cells. The surface antigens you're not going to see as foreign.
Right.
Yeah, I think that, this is what's really exciting for my company. We license out to companies all over the world, and when Vince came to me and he started talking about stem cells and the idea of just transfecting your own cells, it gives us the ability to not only reduce the cost of the gene therapy using less, transfecting the stem cells and going for a long-lasting regenerative cell that's in your body so it can rebuild you over years. But it also gives us the ability to access people who couldn't take a gene therapy because they can't take any hepatotoxicity. They have liver failure or other frailty issues that might make it harder for them to take a vector delivery gene therapy directly. And so not only can this potentially reduce the cost, but actually create a long-lasting gene therapy. As I was telling you, the gene therapies I took, how long generally we think they're going to last is how long those cells that they're in will last.
And you could also see an immune reaction to the AAV carrier, right? Which
Yeah, we've worked over 5 years to overcome that. We can redose. It is in the scientific literature that we can redose. There's usually less transfection rate with redosing of AAV, but we can avoid almost all immune reaction now.
That's great.
Which is great, but we went back to the drawing board with CMV for that very reason. In animals, it's redosable over and over and over again and could carry up to 50 times what AAV can.
Cytomegalovirus. So for me, what's fascinating about this is it's instead of using a virus to carry the genes in, you're using your own cells as the carrier. Yep. It's like the perfect Trojan horse.
No immune issues
and
at all.
No immune issues. And then these cells, because they're your own cells, they were more likely to take up residence and remain, versus if there's someone else's cells with different surface antigens where your immune system might eventually knock them off. Mm-hmm. So what kind of life expectancy do you expect to see on these? How often will you want to redose? And by the way, you can create the stem cells and you can create a large population and dose yourself every so often. How do you think about that protocol?
Well, so one of the things we're looking at, in fact, we both did this when we did our clotho AAV therapy. We looked at our clotho levels before and about a month later. So now there's tests you can look for how high did those proteins actually go, so you can see was the gene therapy effective, and we both saw dramatic increases in clotho within 4 weeks. So this is pivotal because basically what this therapy is designed to do is to undo or replace all the loss, your functional loss. Like you lose your muscle mass, you lose your cognition. But if we can measure the changes in the proteins that are responsible for that, which we can, so now for the first time, we're looking at the potential of restoring lost function as we age. And
which, by the way, is the whole reason for the XPRIZE we launched.
Well, and then
you could have saved me a lot of money by just doing this earlier.
You could just give it to us now.
Okay.
But honestly, the XPRIZE is looking for cognition, muscle,
and immune.
And immune.
Yeah.
Well, you have H-TERT, follistatin, and clotho.
Yeah.
And so these are the 4 genes with PGC1 alpha. we're going to be able to upregulate NAD, ATP production, which is another essential hallmark that we want to go after. But I truly believe we're going to be able to enhance all three of these lost functions for people as they age. And I'm thinking, and I don't, Liz, you can say your comment, I think we're looking at extended health span by at least a decade or two, and probably longevity by at least a decade.
So for those, I mean, I think you intuitively know this, right? But lifespan is how long you live, how long your heart is ticking. Yeah. Health span is how long are you in a great shape, you know, to enjoy your life. And historically, what we've seen, at least in the US and most of the developed world, is a longer lifespan, but your last 20 years are in pain and decrepitude, which is like ridiculous.
And there's an amazing graph. I know that everyone here is above average, but for the average
by
person
definition
in the United States, actually you don't go above the consumption line, meaning that you make enough money to support being alive on the planet until after the age of 25, and most people drop below that by 59. Okay, so your money earning time, or your earning time to support your lifestyle and your life, is very limited. So what that would tell most people is that by the age of 30 you should buy a house, stay in that house for the rest of your life, and don't move. Try to age in place as much as possible. So we really have to change this paradigm. I mean, China alone will have 100 million people in ill health within the next 3 years. They're moving incredibly fast on this. We need to take this very seriously, because we're not just talking about extending the party. That's what it will do. But your most valuable currency is actually time. And so in order to get the most out of your time and out of your life, we need to extend that health span. It's really critical, not only to your own fun and enjoyment, but to the whole social services of the entire globe.
How much, let me ask you guys the question that everyone asks me, how long do you think you'll live?
For me, I think, my son's disease got me involved in this. When I first started, I almost feel like my first 2 gene therapies were almost a public burning. They were like, I was so upset that we had sat on technology for decades that could have been extending health span and saving lives. 36 million people will die this year. 15 million will die prematurely. Every 30 seconds, someone's dying of a heart attack. I cannot implore you more that you need to take this very seriously. Living forever didn't matter. Proving that we could actually cure disease is what mattered to me. Now, I actually have shifted my thought process, and I actually think that we could live an extraordinarily long time. If you're healthy...
What is that number?
As we
tough.
plug the holes,
yeah.
If you're healthy, what do you die of?
Yeah.
Can you answer that question? If you're healthy.
If you're healthy, you die of boredom. No.
You might die of a natural disaster. I mean, really nothing can get in your way. If biology tells us that...
And by the way, I'm going to put this slide up here, so
sure.
If you want to get more information on Regen Cell, you can grab that. So, I'll put it this way. So Ray Kurzweil, Aubrey de Grey have a concept called longevity escape velocity. Yep. Today, for every year that you're alive, science is extending your life typically for a quarter of a year, maybe a third of a year. But in the decade ahead, and again, please think of this decade as very different than decades past, there's going to be a point where for every year that you're alive, science is extending your life for more than a year. And so for me, that's the way I answer it. I want to target longevity escape velocity and have that option. Kurzweil thinks that is by the year 2030, 2031. Speaking of George Church and David Sinclair, they put it at the mid-2030s. The point being, it isn't 50 years or 40 years, and your job is not to die from something stupid in the interim between now and then.
I can't put a number on it. I'll let you try to put one, because really regulations seem to be the biggest thing that's holding up the technology.
So I know mice are not people, but just giving back young stem cells, there's multiple papers that just giving back this younger stem cells to the same genetic mice, they live 40% longer than maximum lifespan.
Yeah.
So let's say it's 20% in humans. Your 20%, maximum lifespan is 120 years. 20% of that's another 24 years. So I believe 100 years at healthy time, and the next less than a decade is possible.
So I want you to think about it in the following way. Our ability to understand, you have 40 trillion cells, every cell's undergoing 1 to 2 billion chemical reactions per second. There's no way any human can understand this. We're tinkering, but AI is going to be, digital superintelligence, again, by all accounts, within this decade, is going to give us the ability to understand why we age, how to slow it, potentially stop it, and reverse it. And these technologies, for me, are a bridge to a bridge.
It's exactly what we were talking. One of the reasons we create a regen cell is to...
And let me use this as sort of a closing statement, if you would, in our last 5 minutes here. And I'm just going to mention, I'll put this up here. If you want information on the book coming out, or a copy of the slides that I gave, or information about any of my stuff, you'll see it there. So your closing thoughts here, Vince.
I'll give and then Liz, I'll hand it to you, Liz. So I think everybody in this room is extremely lucky to be alive at this point in human history. There is nothing like, this is the real renaissance. Okay, we are, every 3 months, what we know about aging and related technologies doubles. 3 years from now, we're going to have 6,000 times more information. And what we're looking to do right now with RegenCell is to bridge this gap, or open up a portal, if you will, to allow people to start reversing the lost function that they've had due to the aging process, but also with reprogramming to slowly start repairing their body cells by these new stem cells that have been reprogrammed, and then they will replace these aged, poor gene activity cells with new cells, which will basically regenerate the whole body over time. So we're looking at a new technology that will repair the damage to increase your health span, and a epigenetic reprogramming process to your stem cells for long-term regeneration. That's just for the next maybe, who knows, 5, 6, 10 years. Yeah. What's going to happen, like you just said, with AI, and then eventually the merging of quantum computing with AI, which will happen in a decade and a half.
Yeah, these are magical times ahead.
We can't even imagine where we're going to be.
Liz.
Well, I think that, as we talk about AI and we talk about biologics, I feel like it is upon me to make sure that biology stays up to pace. So we need to keep our relevance as a human species, and we need to meet AI with what we have and the best of what we can bring to this world. And so, we need to show that we are not the cause of problems, but we are actually the solutions. And I think that this is the next step, is genetic evolution into the future. We start with natural human genes, making ourselves healthier, stronger, smarter, faster. And we keep pace and we keep relevance, and we use AI to help us design a better future and a better path forward.
It's fight against the dying of the light. You don't have to accept what you've been dealt. I think I'll close with that. You don't need to accept the deck of cards. Genetically today, with CRISPR and advanced CRISPR molecules, you can go in there and edit your genome.
Yep.
We're also able to begin to understand which genes convey which benefits, and then to dose ourselves with those genes, that software. There is work going on around the world. I invest in this. I've got a large $600 million biotech venture fund. We're regrowing organs, right? Mm-hmm. Literally, there are at least 4 amazing companies. One of them is George's companies, regrowing hearts, liver, lungs, kidneys, not brains yet. And then we're beginning to understand the fundamentals of the human brain, right? We just saw the connectome of the Drosophila, right? The being able to understand the wiring of not just the neurons, but all the synaptic connections that make up a fly. The mice will come next. At my Abundance Summit this year, I'm going to have the CEO of a company who believes he has the technology to be able to analyze the connectome of a human at a very low cost. So the whole field of brain-computer interface is coming. It's an extraordinary time. You have to be careful not to project linearly what has been happening in our lives into the decades ahead, because we're in the most non-linear portion ever of the human species. Now, for me, I think it's the most exciting time ever to be alive. And I'll close by saying, remember that life is short until you extend it. Let's give it up for these two amazing individuals.
How cool is it to be on the stage? Usually I have to give a talk from like the very fundamentals all the way through, and then Vince would come in and give a fundamental talk. I mean, you actually had all of the parts. I've never, ever been on stage with anyone who I just had to throw some things out, and then you would bridge every single gap of the science. Thank you.
My pleasure, my pleasure. Anyway, great job. See you guys tonight.
That's amazing.
Thank you.